Hello there, I'm back again after a long time with a new presentation. Well, we have finished the resins and chemical parts of our research, and from this session we will talk about the mining operations, and we will explain 4 different items that we want to make them more certain by resins. Okay, as you can see on the slide, here are 4 different types of rock formations and products. These 4 items are laboratory specimen, rock slabs, rock blocks, and in the end, the faceworks in mine sites. For each one, we have different methods that I will explain them in different sessions. Today, I'm going to talk about the laboratory specimen, and I will extend it by using an article which done before in China. A rock sample or laboratory specimen is a small measure of any biggest or larger model. Because we want to do mechanical experiments, we get cores from biggest rock samples in a cylindrical shapes. We could get cores from slabs, blocks, or faceworks, then we get them to the laboratory for doing rock mechanical experiments. On this slide, you can see the cores in cylindrical shapes from different types of rocks. According to the American Society for Testing and Materials, the standard diameter of getting cores is 54 millimeter, and the length of the sample is optional. I mean, if you get cores from slabs, it will be shorter than the cores that you get from blocks. Also, the bottom and upper side of the cores should be flat because when we want to do compressive or strength tests, the device doesn't show us the exact result if the sides were scratched or not flat. Okay, the steps of applying resins on the laboratory samples are shown on the slide. First, the core removal from sample and flattening top and bottom sides. The sample must be clean without any pollution. Preparing a laboratory container and pour the selected resin in it. Put the sample in the laboratory container. Be careful about the whole specimen must flow in the resin, and the specimen must stay in the resin until getting repaired. For the last item, let me make a brief mention. According to the resin you choose, the time for curing, mixing, and thickness is different. And that's because of the mechanical and physical characteristics of that resin. Okay, let me extend and explain strengthening rock samples by resins with an article. The title is Experimental Study of Epoxy Resin Repairing of Cracks in Fractured Rocks. If you want, you could search and access to the full text. It's available on the internet. In this article, they use epoxy resin for repairing the shear zones at one of the hydropower stations in China. The technique that they use is growting. Growting is a special technique developed in recent years with the repairing of cracks in rocks. You can see the properties of resins and hardener on the table. Generally, the epoxy resin is a 2-component material, and these 2 components must mix in correct measures. If the viscosity of resin was high, we could use different additives for making less. For example, we could use ethanol. In this article, there are 4 types of rocks in the shear zone. A. Strongly weathered green schist. B. Strongly weathered gneiss. C. Charring gneiss with marble. And D. Charring gneiss. There are lots of cracks and pores in these rocks, resulted in the lower mechanical properties and higher permeability coefficient. The joints and cracks are well developed with poor fissure, and the crack surface is straight and rough. External high compressive stress resulted in the cracks is mostly closed. The laboratory experiments to evaluation the growing effect is based on the borehole coring of the epoxy repaid rocks. The rock core is a cylinder with a diameter of 56 mm. The rock core is prepared to a cylinder with a height of 100 mm and diameter of 50 mm for uniaxial compression and water penetration tests. The uniaxial compressive tests are carried out by the MTS 815 rock and concrete test system. The density, porosity, and uniaxial compressive strength are determined for the epoxy repaid rocks. These parameters are the important indexes of the mechanical properties of rocks. Because of the fractured rock in shear zone has four typical types, so that the experimental tests are carried out for each type separately. As you can see on the slide, the tables show the results before and after epoxy growing. The researchers have get access to these results after more than 28 days. As you can see, all the physical and mechanical parameters get improved. For example, the porosity of weathered green shifts before growing was 16.38 and after growing has reduced to 6.62, and that's a great improvement that epoxy makes. Because of the micro cracks cannot be seen easily, the researchers of this article use polarizing microscopy for detecting and examining the samples. The results show that the filling characteristics of epoxy resin in rocks is dependent on the cracks and pores distribution situation in the fractured rock. The epoxy resin can fill most of the cracks and pores because of the good flow properties and long operation time, and also the cracked surface can be bonded by the epoxy resin to make the fractured rock changes into the intact rock. Okay, in this video I try to explain the straightening rock samples by using epoxy resin with an example. Of course, there are a lot of things to know more in the mentioned article. I just want to make it clear by telling the summary of that. In the next video, I will talk about the rock slabs again by using an article and even a real video of some factory. If you like this video, please subscribe it. Good luck!